something I noticed. So if I construct a map and then copy image, let's open it up in Photoshop. Just so I can like draw on it. What I noticed a lot of you doing were, is that a lot of you were putting your, a lot of you were making it pixel by pixel. So I'm not even gonna count, but let's say like there's 100 something pixels on this side and there's like 200 pixels something on this other side, right? A lot of you were drawing your 2D arrays pixel by pixel. Don't do that for a few reasons. One, you'll have like a harder time describing each individual tile and how it fits into the room. Whereas if you just abstract the idea that this is one room and then draw that in, you'll have an easier time. I'll show you what I mean. And this is something we'll get into when this is something actually we're going to be talking about this week and next week when we talk about objects. Is we don't have to always necessarily. It's hard to describe. Let me think. You don't have to represent everything in a one-to-one relationship. Sometimes there's different ways to represent real life things within our code, within our program in a more abstract manner. And in general, you do want to abstract things. When I say abstract things, I'm saying, for instance, suppose you were designing a box of a collection of gears. Okay, you wanted to, I don't know, you're manufacturing gears. Would you rather design gears that are slightly a couple millimeters bigger or smaller to have like every single size possible, or would you rather design gears in certain increments so that they'll mostly work in most implementations? Like you won't have to custom fit them, right? You'd rather design stuff in a more general pattern, stuff that'll fit into a pattern. You'll want to have mold. You'll want to have things that generally describe stuff rather than being trying to perfectly one-to-one describe everything. It's hard to explain without a good example, and I don't have one offhand. But what I was going to show you for this map, rather than trying to like draw all of these, I'm just going to be like, you know what? I'm just going to say there's a grid line over here. And then I'm going to say there's another one over here. Oops. I'll put another one over here. And these are kind of mostly random. I'm just putting them in ways that I think is going to get the most rooms in a single block. Maybe this one will make like a little bit bigger. Anyways, and then just pretend that I'll just go ahead and do it for the rest of this. Go like that. And then we'll go like that. And then we'll go like that. I'm just trying to position these grids in such a way that like I think it'll maximize ease. This is where we can be a little cheaty. I'm going to put this over here because I see a lot of rooms, a bunch of rooms kind of form this natural line over here. So we'll put that. We'll put another one over here just because I said so. And then we'll put one over here. And we'll put one last one over here. Okay. And let me change the color to yellow. Okay. So I'm going to say this is room 23, right? Because that's what it's at. Red's no, or yellow's no good. Let's make it green. So we're going to say that this is room 23, right? Because that's what it says below. Over here we have, we can say, this is room 2, and this is also room 2. Oh, we can't actually do that because there needs to be a hallway in between. Oh, maybe the hallway, we'll put it over here actually. We'll say this is the hallway. And then over here we got room 19. And then I'm just going to say, there's another hallway over here. And maybe over here we say, okay, we can't exactly have 2 adjacent rooms like this because there's no, like there can't be a room here. There can't be 2 rooms here. So we'll just say, okay, both of these are just going to be room 14. And then we'll have another set of hallways over here. I'm going to ignore room number 1. I'm just going to say you're a hallway. And maybe I'll even say that this is a hallway just because I feel like it. This will be room 11. This will be some more hallways. Maybe this is room 22. This is room 23 or 33. You see what I'm doing? I'm dividing up this map so that how do I describe it? I'm dividing up the map in such a way that it'll be easy to easier to represent with the 2D array, right? I'm making nice big squares. I'm generalizing areas. This way I don't have to render this thing pixel by pixel. And you don't have to accurately print out every single room. There's way more than 5 rooms here. I don't need that many rooms, and I don't want that many rooms, because then there's going to be a humongous dungeon for me to design for this project, and I don't want that. You know, we'll say over here is room 8. This is also room 8, we'll say, and, you know, maybe this is room 28, and I'll say there's like a little hallway over here connecting these. You see, I'm going pretty like just free form with this. I'm not sticking too hard to the map. The map is there more so just as a guide and some ideas and inspirations. And we'll say this entire thing over here is a hallway. I noticed a lot of you also were like representing walls when you wrote these things out. It's great that you guys are trying to make your dungeon map look neat and use special squares and stuff. I don't need a map. The map is there for more so for my personal diagnosis. Just so between I can look at your on paper design, and I can make sure you implemented that design as you wanted to into your program. So really the map is there more so as a tool for me to make sure everything is working as it should. I'll say there's a room over here, hallway. I'm just gonna make this a hallway just because, and then, you know, maybe, yeah, and then you'll put your entrance and exit. Is that making sense? Is that making more sense, giving you guys some ideas? I mean, it's too late to go completely, I mean, it might not be too late. You guys might be able to squeeze it out, but maybe it'll give you ideas for how to rethink how you're representing your dungeon. Maybe this is like an easier way for you, right? Is this kind of making sense? Some sense? Is it clicking, or are you guys still totally lost? Give me on the participation board, give me a thumbs up if it's making sense. Give me a thumbs down if you're totally lost. Okay, most of you are getting it. All right, cool. I realized something as I put in this project. A lot of you have never, I don't think many of you have ever played or heard of or know of text-based games. So that was a fun little thing. Because when I first introduced the project and all of you guys had these questions, I was like, why are these guys not getting it? It's a text-based game. Like, what's there not to understand? And then I realized, oh yeah, like there's been like 20 plus years of graphical games. Oregon Trail is still pretty graphical if you think about it, because I mean, it's mostly text-based. I would say, actually, now that I think about it, yeah, it's mostly text-based. They do use some graphical stuff, but it is also a lot of text. But when I say text-based game, I mean, there are some like dungeon crawlers back in the day, as it were, even before my day. And that's what people would play. I'm trying to remember the names. I know I knew them at one point. And there's one on the tip of my tongue, and I just can't remember it. But anyways, that's neither here nor there. So that's kind of hopefully gives you guys a better point of reference for your milestone 2. Remember, you have until the end of the day tomorrow to finish that. Any specific questions about that milestone? Anything you guys might have specific that you wanted to know more about with that? Because otherwise we're just going to go into what today's all about. No milestone 2 questions? Let me close the door. Okay, so today we're going to talk about classes and objects in Java. And this goes not to just Java, but obviously it applies to all object-oriented programming. So what do we mean when we say object-oriented programming? What does that kind of mean? What do you guys think that means? I know you guys have heard talked a little bit about objects and classes in your 210 course. Give me something about what you guys learned. What do y'all think object-oriented programming is all about? And you guys can unmute and talk if you want to, or type in the chat. Either one is fine. Yeah, object-oriented programming is about objects. That's a good guess. Let's go a little deeper than that, though. Like, what is the role? What is an object in Java? Yeah, Mario, that's exactly it. It represents real life things. We use objects to, because if we think about stuff in real life, most things in real life have states and behaviors. And this is a term that gets used a lot in object-oriented programming. States and behaviors. States are things, descriptive things about the object, and behaviors are things that the object does. The example that always gets used in these Java tutorials is if you think about a cat, cats have like a fur color, they have a name, they have a height, a weight. They'll have, you know, maybe we can use a char to represent if it's a male or female. We have these sorts of states that describe the cat. Then the cat has behaviors. The cat will run. The cat will eat. The cat will throw things off the table. The cat will scratch you, you know. There's all these different things that the cat does. Those are methods. Methods describe behaviors. Methods describe how things behave and function. And states are variables or traits describe what they are. Does that kind of make sense? Cool. And we're going to talk a lot today about instances. Because this is one thing I noticed that gets confusing a lot to a lot of people. Have your 210 instructors talked about what the word static means and why we've been using it everywhere? I mean, you know why you've been using it everywhere, because you call everything directly from the main method. But what does the word static, the keyword static, mean in Java? Do they talk about this at all in 210? No? Okay, cool. Well, we're going to talk about it in here. So let's go to the whiteboard. I'll be right back. I have a pen tablet. It's going to make it a lot easier for me. Okie doke. Think about sharing it in all instances of a class? Not quite. Okay. Let's go to the whiteboard. Okay. So when we have a class, and we'll just call it foo for now. We have a class foo, right? We said that our class foo has certain what? What do classes have? Yeah, class foo has states, and what else? What are the other things that classes have? Data fields would be under states. Behaviors, exactly. These are abstract terms used to describe, in the case of Java, switch colors, methods, and over here we got variables. So suppose we say we want our class foo to have, and let's make this a real class actually, not just foo. So we'll say that this is our class of cat. We'll stay with the cat example, right? And we said that the cat had a few things underneath it. Under states, we said it had a name, age, sex, fur color, and then we'll say weight. And we'll just say height to be thorough, right? Our cat's got all these things, and then behaviors, the cat can meow, the cat can eat, the cat can run. Oh, no, the cat can't bark, dummy. Stupid. Cat can meow, eat, run, we'll just call this throw stuff off the table. It can scratch, and we'll just say hunt, right? Because who hasn't had their cat bring in something from outside? Cool. Where was I going with this? Okay. Now, in our Java, I'll make a little dotted line over here. In our code, and I'm going to write code. How do we, like, let's say we make a new object. We'll say cat. We'll call it whiskers. It's equal to, how do we create a new cat object? Yeah, new cat. And we'll get to constructors here in just a minute. But for now, we're just going to talk big picture stuff. So when I create whiskers, we have a new instance of this class cat. Let's say this is over here. We have a new instance of all of these states and behaviors inside of this instance that we've named whiskers. Now, if we make a new cat, and we'll call this sprinkles. New cat. I don't have a cat, so I don't know what people name their cats. Sprinkles. All right, we've got two separate instances of the cat. Both whiskers and sprinkles have a name, age, sex. You know, they can all meow, eat, run, like all this stuff they can do. But the states in whiskers are implied to be different from the states in sprinkles, right? These are going to be two different states, right? Whiskers is name variable, age variable, sex variable. All that stuff is going to be different values. Well, at least some of them will be different values than sprinkles. These are separate instances, right? If we think about it, this class cat is like a blueprint, and then these are implementations of that blueprint. Another way I like to describe this is, imagine that the class is a blueprint for a house, and every time you instance it, create an instance of that class is a new house being built in your neighborhood, right? Classes work very much the same way. The blueprint, you can tell when you're walking through like your suburb neighborhood, all the houses are like kind of similar, but different enough. Like there's a couple things that are different, so that doesn't look like it's like the same 8 houses over and over and over. But you can still tell that it's the same 8 houses over and over. Same thing with classes. Each class has a few things that are a little bit different. Each instance of it has things, states of it that are a little bit different, but the behavior and functions of it are exactly the same. You know, even though these houses might look different, they still provide plumbing to you the same way. They still have the same central heating and air. Excuse me. They still have the same function of doors and windows. All their functions and behaviors are still the same. They're still a house, but their states, the way they're described and represented, might be a little bit different. And that's the same thing between here. So when we say static, what this word means, static means, okay, let's start with this. A lot of words in Java come from real life meanings. So when we describe something as static in real life, what are we saying? What does that mean? Does anyone know? Yeah, non-dynamic. And what does dynamic mean, Cameron? Exactly. Static is the opposite of dynamic. And this is a very core thing in a computer, in coding in general, is the idea of static versus dynamic things. Static means that they don't change. Dynamic things means they do. When we say something, when we describe a variable as static, it means it will not change between each instances. So suppose we have some value, oops, we'll say, have a Boolean of is feline. And we have this set to true. And it's static. This means that anytime we create an instance of cat, this will always be set to true. At any time, like let's say we decide, oh, Sprinkles is not a feline. We set it false to Sprinkles. Well, it's going to be false for Whiskers as well. And actually, why don't we go into Java real quick and we will create, and this will be a good time to talk about what do you call it as well? I'll make a new folder. This will be a good time to talk about constructors as well. So, I got to share my screen back to desktop. I pull up the chat. And if you guys have any questions, feel free to throw them into the chat as I'm going. If what I'm doing is not making sense, please tell me to stop and re-explain, because I know I'm kind of moving a little fast. Demos, cats. And we'll create a new cat. And what do we say our behaviors were? We had a string name. We had a char sex, int age, double weight and height, we'll say. And we'll use metric system. Using metric system. And then what else did we say? Oh, we said there was a static Boolean is feline. And by default, because it's a cat, we'll say this is true. Move this out of the way. Oh, I can't do it like that. True. What else did we describe about the cats? Let me check the whiteboard again real quick. Oh, and color. Okay. And string color. Okie doke. So, got all this stuff. Now, we want to make a constructor. Who can tell me what a constructor does? Oh, no way, Ronnie. Does the refrigerator also refrigerate? Talk a little bit more about what that means. We can create object. No, we're creating an object here by building this class. What happens with the constructor, what we're doing is we're instantiating it. Initialize is close, Vanessa, but we have to be very clear here. We are creating an instance of it, instantiating it. Because initializing just refers specifically to giving value to variables. Instantiating it is what we use to describe objects, because objects work a little bit differently than variables. Rather than assigning a value to it because it has many different values it could have, we're creating an instance of it. We're bringing it to life. We're making, this is just a blueprint, what we're building here. This is not an actual object just yet. This is just a blueprint. What we want is to create a, actually, I'm going to rename this from cats to pets. You'll see why here in just a second. Rename pets. You see why as we go further into this. But yeah, so there's two different types of constructors that we could have. We can have, so the way we do a constructor is we just say public and then the class name. And then this is what's called the default constructor. Constructors. When we don't have any parameters, it is just a default constructor. What the default constructor means is that if we create a new instance of an object, of the cat object, like let's say we said cat Paul is equal to new cat. If we went just like that, then we'd end up calling the default constructor because we've not given any parameters. So we want to create the default instance of it. And what we do with the default instance is we generally, when you're creating a default constructor, you want to be sure that all of these variables that are not initialized up here have some value initialized. Because remember, we talked about if a variable is not initialized, what value does it have? What is its value when you try to call it? Like suppose I didn't initialize, yeah, null. And the problem with null is, let's say we wanted to add a number. Let's say we wanted to say age plus 3. We say our cat age 3 years. Well, null plus 3 is an error. It's not 3, it's an error. Because null is no value. It's not even 0. So like Java's gonna be like, yo, I can't do this. I don't even know what age is. I just know that it exists, but it has no value. So what we want to do in our default constructor, and I've said this before, some compilers of Java are smart enough to initialize the 0 value to uninitialized variables, but you can't depend on that. Because what happens if you deploy your code into an environment that uses a very old version of Java? You're not going to have that safety net. So you need to make sure you're programming in a way that leaves very little room for doubt. So we'll say name is equal to empty, color is equal to empty, sex, we'll just initialize this to an empty char. We'll just make it a space, how about that? Age is equal to 0, weight is equal to 0.0, height 0.0, you guys get it. We don't need to initialize is feline because it's already initialized at the start here. And I'll make a demo with this here in just a second. And then next, after the default constructor, what's the other kind of constructor we have? Who knows? Or who remembers, I should say. Yeah, constructor with parameters. Generally what we call that is the explicit, is the easy name, or the parameterized constructor. And this is for when we have like cat Paul is equal to new cat, I'll say Paul, orange, etc. I completed a quest on Witcher. Public cat, and we'll say, so this is another place I want to show you something new, the keyword this. And we'll get to that here in just a second. String name, string color. Notice that I'm naming my parameters the exact same as a local variable, and that is totally okay, and I'll show you why here in just a second. Char sex. Int age, double weight, double height. Okay? Now, if I say name is equal to name, well, what's going on? Why is this grayed out? I want this name to be this name. But why is Java getting confused here? Nabil, you are correct, but I wanted to break that down a little bit of why we use this. So what Java thinks is happening here is it thinks that I'm saying, well, the parameter name is equal to parameter name. Well, no shit, Sherlock, because that's how it's coming in. Yeah. Because they're both called name, we need to differentiate. One of the names is attached to this object, is attached to this instance of the cat object. So we differentiate that by saying this. So now, as you can see, it's purple, same as the one up here. And the purple is what defines us, lets us know that the variable is local to the variable is set to this object. And then the name is the parameter. And then we repeat that for all of it. Color. Is this confusing to anyone? And it's okay if it is, because we'll break it down some more. If you're not getting it, help me out by asking me some questions. What are you confused about? Because if I just explain it again, I'm going to explain it exactly how I explained it before, because this is one of those things that for me is really basic, but I understand this is new for you guys. Oh, there's nothing different between those two, Ronnie. If you wanted to name your parameters differently than what's coming in, you're totally okay to do that. The reason why you do this goes back to what we talk about with conventions. It's much easier for someone implementing your code to say, okay, this is the constructor, and the name goes to name, color goes to color, sex goes to sex. I mean, yeah, you could say like param name, param color, or like just put an X or something, but it's much clearer in a very quick read what these are when they relate to, if the name matches here. And most people, is this the same as new? No. New creates a new instance of an object. This is a quantifier. This says that, hey, in this reference of name, we are referring to this instance of name, the instance of name in this object. So Ronnie, to your point, you can make them different names, but it's generally, most people do it this way, and the reason they do it this way is to increase readability of the program. So that when someone in the future is maintaining your code, they can just quickly look at these lines and understand what's happening without having to be like, okay, well, let's match this to here, this to here, this to here, this to here, right? It'll be much more easier to follow the pipeline when you're being consistent with your naming. And like what happens if, or even a better idea, like when they, here, let's make a pets driver, new class, call it pets driver, public static void main, string args, and we'll say new, or cat Robert is equal to new cat. And we'll just say, as soon as we get to the parameters, it tells us exactly what we need to put in here, right? This is another reason we do it. A lot of new IDEs have this. And when you're being just very clear with what your variable names are, it's so easy for people to be able to use your code. Because if we name them something differently, I'm not saying that the code, like they might be able to figure it out, but it's just the coder after you will thank you for naming things clearly in this manner. So those are the two different kinds of constructors that we have. We have the explicit constructor and parameterized constructor. Let's build, so these are the states of cat, and let's build some behaviors of cat. All right, and one other thing I'm gonna do here, I'm gonna set a private variable, private. We'll call this ID, or int ID. We'll have it uninitialized. And I could initialize it through the explicit constructor, but I'm not gonna do that because the ID is gonna refer to, when you get a chip put into your pet, we're gonna emulate that. We're gonna say this int ID is the chip that they put into your pet, the tracking chip, so that if your pet ever gets lost, they can geolocate, or the pound, if they find your pet, they know to call you. So we're gonna also demonstrate getters and setters here because of that. We'll do that. Getters and setters. So this is kind of a contrived example, but bear with me. While all of these things, the name, the color, the sex, the age, the weight, the height, all of these, and if it's feline, all of these can be easily discerned by just looking at the object. We don't know what the chip ID, we don't know what the chip ID number for your pet is, right? Because we need a chip reader. We need a special tool to do that. So we're making it private. That's not something we can immediately know by just looking at the pets. So we set that to private for our model. And we're gonna say, okay, you need a special tool to set it, and you need a special tool to retrieve that information as well. So we're gonna write a public void set ID is equal to int ID. This dot ID is equal to ID. And then we'll have a getter, and I'll talk a little bit more about them here in just a second. Get ID, return ID. And note here, I didn't have to use this because there's no conflicting names. Some people in their Java code put this on everything when they refer to a class variable, and you can do that, but Java developers are a fickle bunch. And if one of them doesn't like this naming convention, you're going to get some very nasty comments on your GitHub. They'll just basically make fun of you for typing in stuff that you don't need, and they'll call you stupid for it. And maybe not the same way, but That is what people might think when they see that. It's basically redundant. You don't need it. If there is no conflicting names, you don't need to use this. So for getters and setters, why do I need getters and setters for a private? Actually, I'm gonna come back over here. So if we say cat, my cat is equal to someone name, what's the name of their cat? Okay, our cat's name is Dog, because he's my cat, Dog. And his color is gonna be brown. Hello, can you please come back? I need help. Oh, duh, new cat. Name is Dog. Help me out, thank you. Brown. This cat is a female, we'll say. This cat is gonna be 5 years old. And it'll be, let's say, I don't know, 8.5 kilos. And then it's gonna be 0.3 meters tall. So we have all this, and one neat thing I can do is I can say, you know, I can print out like my cat.name directly. I can access this variable directly. I know the cat's name because when I look at it, I see the tag that has its name on it. I can't, however, say my cat.id. I'm gonna get an error here because ID has private access. What does private access entail? We've never really talked about access modifiers, but we're talking about it now. What do you guys think? And I'll just be explicit and I'll say these are public. Copy that over here, over here, over here, over here, and then that one is private. Yeah. Yeah, private, basically, public says all classes can see this. Public basically says anyone can look at me, but private says only this class can look at me. Right, because different classes can't access private variables, we circumvent that by having getters and setters. Getters and what this allows us is, this brings us closer to what's called encapsulation, where we control the flow of information. This becomes very, very important when you start talking about, you can do protected, but protected, so if I do protected here, I'm gonna be able to get the ID still. Why am I still able to get the ID? Okay, that's my fault. I should have pulled up. Java access keywords. There's a table. I'll open this image in a new tab that tells us what all of these keywords means. So basically what this table says is, depending on where we're trying to access it from, if something has that keyword, can we access it? So if we're in the same class and they have the default keyword, can we access it? Oh, sorry, the default's not a keyword. Default is when you don't define one. This is by when I leave it undefined, when I don't say protected, public, or private. These are the defaults. All that default does is stuff from different packages cannot access. And don't worry too much about the subclass stuff down here. You guys aren't gonna learn that. Subclass basically means is referring to abstract objects and inheritance. We're not getting into inheritance in this class, so ignore the same subclass, these two rows, ignore the two yellow rows. The green ones are what you're interested in. When it says non-subclass, it means a sibling. Fuck, I'm not supposed to use basically it means another package in that, another class in that same package, but not a class that inherits from it. And again, don't worry too much about what inheritance means. Just pretend instead of subclass, it said class, right? Instead of non-subclass, it said class. Just look at the green rows. That's the only ones you need to know. So if it's the same class, everyone can access it. If it's a different class in the same package, then with default, you can access it. With protected, you can access it. With public, you can access it. But private, you can't. Private very specifically means only this class can access it. What protected means is only classes within the same package, AKA the same folder as me, can access me, right? Does that make sense? That's the difference between protected, because cat and pets driver are both in the same package, and we know that because we've defined it up here, right? Package demos.pets. And the reason why it's demos.pets is because we go into the package demo from the source folder, we go into demos, then we go into pets. So I need to make this private. That way I can make sure no one except for, unless they have a chip reader, which is the getter, can they get that? Can they see that value? So that is the difference between protected and private. Does that make sense? Give me a yes or no on the board. Cool, all right. Awesome. So I'm gonna demo something, my cat 2. So you go to new cat, and we'll say this cat's name is Garrett. Garrett is red. Garrett is also a boy. Oops. Garrett is 3. He's 7.2, and he is 0.25. Let's see. Okay. So if I have my cat dot is feline here, and we'll do it over here for my cat 2. Let's go ahead and build this application pets driver. Okay. I'll get to talk more about what the driver class is here in just 1 second. But yeah, so let's go ahead and run this. Both of these are going to print out true, right? Because the default value for is feline, you see that over here, it is a static variable that is true. But let's say Garrett was in fact not a feline, right? I'm going to say my cat 2 is feline is equal to false. Now, if I print both these back out, what do we think is going to happen? So first to print out true, what is it going to print out here, you guys think? I meant for these 2 lines, excuse me. How many think line 13 is going to print true? I'm going to clear the board. Give me a yes if you think it's going to print true. Give me a no if you think it's going to print false for this specific line. Okay, well, let's find out. Let's press play. Whoa, it printed out false. Why did it do that? Why do you guys think it did that? Remember, static means, I think I said this earlier, static means that only one instance of this variable can exist. Remember in the picture I drew? Yeah, but I only changed it for my cat 2. So why did it change for my cat, the first one? Why did it change for dog and not just Garrett? I'm trying to think if that's a good way to describe it or not. Belongs to the class. That can be misleading. Because if it belongs to the class, well, this is an instance of a class, so it technically belongs to me. There's one important thing that's different from the isStatic variable than everything else. It is static. What that means is only one instance of it is ever created. Even if we create multiple instances of this cat class, exactly, Mario, only one copy of isFeline ever exists, and it's shared between all of them. And this is like a really contrived, stupid example. You normally wouldn't do something like this. But yeah, this is one thing you can use static variables for. Another reason, sorry, one second. If it wasn't static, it would be true, false. Exactly. Static count. Never heard that one. Static count Java. Use static count instead. I don't know if that exists in Java, buddy. I mean, it's a counter. Yeah, we can. I don't know if that's what you meant. Here's an example where they use a counter and the count remains the same throughout all instances of the counter. Yeah. So here's another example of using it. I was actually going to go to a different example of what we might use static for. This, like I said, this is like a super contrived, dumb example, but one thing we might use static for is so that we don't have to keep saving an instance of an object. If we make a static method, then we could do something like, for instance, with random, import Java util star. So if I say new int rand is equal to new random next int. Oh, it didn't work. Ah, fuck. I thought this was static. I was so certain that this was static. We can create a static variable. So basically, we could just keep using, forget it. I have an example that I could have shown you from one of my projects, but that's going to be way too confusing to explain. Just for now, know that static creates one instance. So the Zhejiang is right. The counter is a much better example. Let's say I created a counter class and it had an integer count that was started at 0. And anytime we wanted to create a new counter, anytime we create a new instance of counter, it gets incremented. This is still kind of like a contrived example because you'd never do something like this, but it's a good demo of how static variables work, right? So what's happening here is in the counter constructor, first of all, when we first create counter, we initialize on the stack a integer named count. And because it's static, we won't overwrite its, it's only going to be one instance. So any change that get made to count is going to get made to that one count variable in our variable stack, in our program stack. And anytime we initialize or instantiate our class counter, we're going to increment it. So as you guys can see here, it tells you what the printout is going to be. So when we create C1, this happens. So count becomes 1. Then we initiate a new counter, and then this happens again, and it goes to 2. What do you mean, Cameron? This is just like a separate example. This is just a better use of the static variable, is why I'm showing this to you. This is a better, more practical example of why you might use a static variable. A static variable just means only one instance of it is ever created. Only one instance. So I am going to be writing pre-lab for chapter 10. You're not going to be doing this. I'm going to write a quiz, but it'll be open starting tomorrow because I need to write it first. So don't do this. And in fact, I am going to hide this from the students so that you guys don't accidentally do something you're not supposed to and then get really angry because you're the one who didn't listen to the instructions. Down here, and we're going to hide that. Okay, static means only one instance of it exists. So if we go back to this count example, because only one instance, when we create this, only one instance of it exists. And the value of it it can't be reassigned, basically. So even though we're creating a new static int, because this is a declaration initialization, it's going to say, well, hold on, we've already declared and initialized a static count. So for future creations, I know it's kind of confusing, but just bear with me. When we call counter, when we create new instances of counter in the future, because we've already declared and initialized an integer count, these ones don't reset it. Because it says, oh, wait, hold on. We've already created this, so I can ignore this line after the first time. But then when we come here, it's like, okay, but we can still change the variable, so we're going to keep incrementing that. So from here, count goes to 1 because we make it go, when we use get count over here, it prints out the value of count, and because we use that after we've initialized, we've instantiated a new instance, meaning we've done this, after we've done that, this prints out and gets the value. So here we increment it once again, and then we print it out. We increment it again, and we print it out. And if we run this thing, value of counter 1, 2, 3, just as it said it was going to be here in the comments. This example is isolated from the cat example. These two are separate things. This is just a different example to show the static keyword. And I'm going to tell you right now, your professors are going to love giving you really weird questions in your quick exams where they have a static variable and they modify its value in a bunch of different places to try and make you confused and lose track of it. And they're going to ask you, okay, what is the value of this static variable? And you're going to get confused. Or, if you don't trace it properly, or you don't understand properly what the static keyword means, you're probably going to get the question wrong because that's how they design them to be. So if you're not getting it, ask questions, because static is kind of an important concept to understand. You can get by without actually, no, you can't. There will be some problems where you need to use a static variable. And it's actually a solution you can use in many other places too. Just by knowing that it exists and knowing that it's in your toolbox, you can look for places to bust it out and use it. Anybody not totally set on what static means? Maybe wants more examples or wants more explanations. Who's not getting it, I guess? So how does static apply to methods? Ignore that part. I don't have a good way of explaining that. I could show you a piece of code that I wrote a while ago that used static methods, but it involves inheritance, and you guys don't need to know that just yet. You won't know that until later. So for now, when we put static, it basically just means only one instance of that method exists when it gets called. So all of those methods kind of work the same way. But again, that refers more so with, that has more so to do with things about inheritance than anything else. Oh, I'm sorry. I do know why. Sorry. It's so that I think math.pow is static. So if you ever notice with math.pow, we've never, you see how it's italicized? That italics in IntelliJ means that it's static. So int a, we'll just say that's 2 to the 3. Or sorry, it's called double A is equal to that. And then we have int rand over here, new random next int. So you see that to use the static, because this is not a static method, to be able to use it, I need to create a new instance of random, right? But with math, because this is a static method, I don't have to create a new instance of it. That means I save myself the processing power of creating a new instance of an object. So if I'm going to be doing something where I use, where I'm going to be using the random library a lot, it might not be a bad idea to create an instance of random rand object is equal to new random. Let's say I did that. Because I might end up using this a lot, it's not a bad idea to do this. But if it's a one-off, this is totally okay. If it's one or a couple off, it's totally okay. This doesn't use that much processing power, but I'm just saying in a very big project with limited memory, it does kind of come into play. But this is the difference between static versus non-static methods. Static method is that I don't have to create a new instance of the object that houses it. I can just call it directly. So, you know, let's say I'm building a project where I have some commonly used functions. I could just make a new class that encapsulates those, that embodies those, I should say. That is where you would use static in a method. Does that make sense, Cameron? Cool. Is that making sense to everybody else? Cool. All right, I'm glad you guys are getting it. If anyone's not getting it, by the way, do speak up, because like I said, this is where the class starts to get a little bit harder. This is really what starts weeding out people who, you know, people who will get it and the people who need to put in extra work, I guess. So as a pets driver, now let's talk a little bit about what the driver means. So why is it that we use the static keyword in main? Now that you guys know what the static keyword means, why do you think we use it in the main method of our project? Because remember, static means only one instance of it ever exists. So why might I want to use that keyword for my main method? Yeah, that could be it, Aaron. That could be one thing. Exactly, Ronnie. There is only one starting point. The main method is the main driver program, is the main driving force of my program. And that's why usually, like, when you have multi-class projects, sometimes, not always, but sometimes, depending on the context, someone might name it the driver class, because that's the class that drives the whole program. That's where the program starts. It's the class that has the main method in it. Oftentimes, I won't get into too much. But yeah, there's only one starting point. That is why we have a main. There can only ever be one main method in the entire project. So that is why we use that. So with that, let's transition to what you guys are going to be doing for this coming week. Let's come to your Chapter 9 lab. Oh, the link to this is wrong. This is not what you're doing. I thought I updated these. I'm sorry. Come on. Oh, it's right here. The ATM program. And I will edit it on iLearn real quick. Make sure the due date is correct. Awesome, cool. Apparently, if I do just cutoff date, it doesn't show the due date, which I think is really stupid. So I have to make sure I do this as well. Chapter 9 lab, link, and then I think, what did I tell you to name it? Oh, you're gonna have to submit me a zip, because you're gonna have multiple classes. And I want each class in a different file. Your ATM program, first name, last name, .zip. I'll talk a little bit more about the submission. I'll update the document to talk more about the submission too. .zip. Okay. So what you guys are building this week, you're going to build an ATM program. You're going to build a software that's going to initially offer the user 3 options: sign in, show customer list, or exit. And if they click the second one, then you're going to show the entire customer list, which is over here. So we're going to create a worker class. First, we want to create a customer class. We want to create a customer. We're going to create a class that when a customer logs in, it's going to get initialized and instantiated. And here's all the different data fields with the access keyword that for each of them. So, you know, the first and last name are public, and all their other data we want to keep private. So stuff like their bank account ID, their bank account balance, their alphanumeric PIN. Oh, I forgot this could be alphanumeric. Let's mix this up. YMCA 1E2 BOR G Q. Oh, wait. And we'll just leave the rest of this kind of like that. Okay, cool. So, this kind of leads to the next point. You're going to create a new class called database. Database is going to have an array of customers, and each customer is going to have this information. The reason why the database class exists is when the user comes to log in, what are they going to do? They're going to give us I think I talked about it somewhere in here, what they need to give us to log in. Customers information. Sorry, I wrote this a few days ago. I just needed to review it. There's okay. So when the user signs in, if the user wants to sign in, they must give their full name and 4-digit alphanumeric PIN. Cool. This way you'll be able to use the getters method as well for when you're checking for the sign in. Basically, if a user wants to sign in, if they click option 1, then your program is going to ask them, hey, what's your name? What's your PIN? And based on that information, you're going to search through this array to find them, this array of objects. So you'll have to, for each entry, and in this case, your entries are a row, and your columns are the different fields associated to that customer. Yeah, you're going to go through each of these rows, which is an entry in your array, and you're going to see, hey, is it this guy? You know, do the names match? Does the PIN match, etc. So you'll have to do some error catching accordingly for that as well. And then you're going to have a worker.java, which is basically there to withdraw or deposit to a given user's account. So all of your work done to the user's account will be done to the worker.java class. And then we'll also be able to display the user's balance. After all this is done, and then wrapping through all of this is going to be your driver class. I just talked about what the driver class was just now. Oh, I talked about the login in here. Cool. So actually, let's remove this, because I talked about what they need to log in here. Their bank account ID and their full name. And then once they've chosen that, the main program is going to allow them these options. I didn't include a example output this time because I kind of want to wean you guys off of that a little bit. I think it's better for you guys to learn the kind of confidence to just look at the requirements and be like, okay, I'm going to make a program that based off the description of what my customer said is needed, I'm going to make a program that does that. I won't be too picky on the UI of it, as long as your program does these functions, does these required functions here, then you are totally okay. And then I should talk about submission. When you are done, take all of your classes, zip all of your classes together in a file called tm program, first name, your first name, your last name, .zip. submit it to iLearn. Cool. Your classes must follow the naming conventions given here. Cool. And I'm pretty clear here on like what everything should be named, what your driver program should be named. This should be ATM program, should be the name of your main driver, and all the other class I have it here. Any questions about this lab? Essentially, you're creating a piece of software for a bank that's going to allow users to log into their account, modify their balance, and for whatever reason, the bank wants to show their list of happy customers. Cool. Oh, this part specifically, 3 customers max on each line. So for example, it will be Bob Bobson, John Johnson. Actually, we'll put tabs in between. John Johnson, Mary Marson. And then on the next line, it'll be like Timothy, Gobber, and Bobber. Okay. I want you to print out the names like this. 3 names on each line. What does the worker class do? The worker class will be what is you use to say, hey, this user needs to have this action done. So the actions will be, they can do is withdraw or deposit or display the balance for a given user. So the worker will just have these 3 methods, and what do you think, or I won't give it away. But yeah, you will need to tell the user, hey, this instance of our customer, I need to get this information from it. The worker needs to be able to get the specific customer information. So if a customer is logged in, how are we going to get that logged in customer's information? The worker class is the one responsible for getting that info and displaying it. Does that make sense, Cameron? I know I said it in like a really weird way. So you're going to have a database file that's responsible for storing all the information about your customers. You're going to have a customer class that is named customer that holds all the information that models our customer within our system. So as you'll notice, the customer class has all the same fields as over here, right? It's got the first name, the last name, age, bank account ID, the balance of their account, and then their 4-digit alphanumeric PIN. The worker class is responsible for use the bank, the driver class will whatever class basically. So the program will say, hey, I have this customer object here. Worker, I need you to go into this customer object and show me their balance. Or I need you to go into this customer object and show me their, deposit or withdraw from the balance, right? And note that because these are private, the 2 fields mentioned for, the balance field, because that's private, that's going to be something you have to consider when you're going through this. I don't want to give away too much. I don't think this is that hard. It just is going to make you guys think a lot about classes and access modifiers. For the driver class, I have a worker object which will access data from the database class. The driver class will instantiate one worker object, and then it will also instantiate the database object, which should somehow be storing all the data for our customers. And then, and very specifically here, I said this should be an array of customer objects. So that will be something for you guys to think about. But you are mostly on the right track there, Cameron. I do want to reiterate, each class should be its own separate file. So the driver class should be on a separate file. The worker class should be on a separate file. The database class should be on a separate file. The customer class should be on a separate file. I know maybe in your 210 classes, you've written multiple classes in the same file. I don't want you to do that for this. I want you to divide it up. But the array of customers exists in the database class. Correct. That is correct. And in fact, should create a private customers with the private keyword. So this array should be private, which means the database object needs to have methods that can access the data to whoever queries it. Does that make sense? Because when this is private, basically it will mean that I won't be able to do something like here's my database.array2 or something like that. I won't be able to do, I don't want you guys to be able to do this. I want you to use database.getById, and then, here's the ID over here, right? That's what I'm thinking for you guys to do for that database object. Any other questions? Because we are coming up on end of class. The biggest hint I can give you guys with this project, never forget what your initial objective is. You're writing basically an ATM program. You're writing a program for an ATM. It's going to allow a customer to sign into their user, withdraw a deposit, and see their balance. That is the ultimate goal for this. You just have some parameter, you just have some requirements put by me, the senior developer, telling you, hey, this is the things that, this needs to be private, this needs to be modeled this way, etc. But the rest of it is going to be for you guys to fill in. Don't wait on this, as I say every week. Start working on it now. Let's maybe kind of start sketching it up together. So when I tell you guys to start out your development process by drawing it on paper and sketching it out, let me kind of talk a little bit about let me show a little bit what I mean by that. Clear out my drawings. So let's kind of talk a little bit about how we would model it. So here's a few things that are, let's write out our requirements. So we're making an ATM program, and we're going to have our database. We need to have a class named database. Inside this database is going to be an array of customers. And this has to be, the access for this has to be private. Right? We're also going to have a worker class that can withdraw, deposit, or check balance of a customer. And then after that, we're going to have a customer object that has their name, age, etc. It's going to have all their data fields. And then there's going to be, and then I have to build a driver class, which is going to be the main driving force for this entire program, right? Everybody with me so far on this? It's going to have the main method. It's going to be here in the driver. Everybody with me so far on this? Cool. And our main method is going to have three functionalities. One, sign in. It's going to have to use it if you want to sign in. Show customers, or exit, which will just exit the program. This should be pretty easy for you guys to code. For the sign in, let's kind of talk a little bit about the sign in feature. I'm not going to go into too much detail because I do want you guys to figure it out for yourself. But what I'm trying to demonstrate is if I were writing this program, how I would kind of go about thinking about it. Okay, so we have our database of customers here. For the sign-in, we need to get the user's account ID and their PIN. We're going to get these two pieces of information from the user, and we need to find if they exist in our customers list. Well, our customers list is stored in a database, but the array itself is private. Furthermore, I need to look for something in the array that has these two parameters. So maybe, if we think about what's in this customers list, there's multiple entries of customers, customer objects, and each customer object has a bunch of data fields in it, including their account ID and their PIN. There's other data fields in there as well. So I need a way to be able to pass this information into some method in wherever it's going to be. The location is kind of up in the air. I can decide later, but I'm going to pass it into some method. Then this method wants to go and check for this, given these account ID and PIN. It wants to check for it somewhere within the database array. And because this is private, I probably need methods inside of the database that will then kind of have this back and forth communication over here. And then if it gets it, it's going to throw it back. And if it doesn't find it, I need a way for this method to know, yo, I didn't find it. Maybe if it doesn't find it, we return null, for instance. If we return null, we can easily check to see on this end, like, hey, is our thing null? If so, we can throw an error like, hey, we didn't find you in the database. Your information might be wrong, or you're not registered in our bank. And I will be checking for this as well. If you have some kind of error handling, it doesn't have to be null. You can think of other ways to do it. Sometimes another way to do it is you send back a dummy instance. The name will be something like does not exist. So you can check for that string in the name. It's up to you. But ultimately, you need some way of knowing, hey, was this person found in the database or not? So, and because this is private, I need to have something inside of I need to have some method inside of database, DB, that will be able to query using these fields, right? This is, when I say draw things out, think it through, this is what I mean. Sit down, before you write a single line of code, just draw out the entire program. Write some notes, handwrite, just figure out, how is this gonna work? What am I trying to do? How can I accomplish that goal? Break everything up into little sub chunks like this, and the whole program will become more clear. This assignment is really an exercise in, can you wade your way through these access stuff and think holistically about the problem you're approaching. It's easy, but it's also not, I guess is what I'm trying to get at. Like on the surface, it seems easy, but once when you get into the weeds is where it becomes difficult, and that's kind of how all coding is. There's a lot of just problem solving, which is what you guys need to do. You are presented with this problem, and you need to solve it. I think you guys can do it. You guys have been doing pretty good about all this stuff. I think this is within you guys' capabilities. Any questions before I end class? Any parting questions? Yes, correct. Oh, real quick about a zip. Some people do this thing differently. Ultimately, let's say I just pretend these were my Java files, right? When I right click and I say compress 4 items, it creates a copy of these items into this archive.zip. And I would rename this to, like ATM program Turk Erden, right? That would be the thing I submit. But you don't need to create copies of these files and then put them into a zip. The computer already does that internally for you. Or your OS already internally does that. You do not need to create copies. I've had an issue where some students create a copy and then they zip it and they send it to me, and then that creates compilation errors because the Java file is not named the same as their class. Don't do that. Just select the files you want to send to me, right click, compress to zip, and if you're on a Windows There's a different way for you to do it as well. That's more or less exactly the same. It's just a little bit, the buttons are somewhat differently in Windows. But you could just Google it and be like, how to make a zip file in Windows, and it's pretty simple. I do not believe you, Mario. You can share your screen and show me if you'd like. I do not believe you.